All right, page 70, we're looking at roadworks. Now, roadworks is the last subsection in our quantities portion of this course. All right, and it's quite easy, as you will notice as we progress. Remember, it's all about basic geometry. All right, so let's look at it. Roadways, control layers, and surfacings are seldom a suitable subject for comprehensive measurement. Now, we're not going to find something if we, in a practical situation out in the field, calculate something to the exact last 100 milligrams or something like that. All right. So we're going to get some figures based on some dimensions, but when we order material, this is going to come in excess. Right? And that's where you need to find a balance between buying too much and not buying enough. Where a reasonably long length of roadways of fixed width and without intersection is required, such as a connecting road to a new township, service or works, comprehensive measurement is acceptable. In such a case, the construction of the roadway and shoulders, curbs, and footway, if any, of the control is selected subgrade, subbase, base, and surfacing may be measured by length, scheduled as a comprehensive unit, the widths being stated. All earthworks items for roadworks quantification are as for earthworks dealt with previously. And you will see that as we progress. We're saying that site clearance, excavation, removal of topsoil, all of those still apply. All right? But actually pauses until then. All right, roadbed, treatment of roadbed, and we've got SANS 1200. Roadbed preparation and compaction of material to specific densities. Notice the unit, volume, and bundle. All right, in place treatment of roadbed in intermediate or hard rock. All right, so we're going to be experiencing different kinds of soil conditions, and we may have to basically take that into consideration in our calculations. Now, that will make sense as we progress. Construct subbase, once again, still sands. You take it from borrow pits, commercial sources, and we use some stabilizing agents such as lime and cement, all still reduced to cubic meters. All right, base. Construct the base of material from borrow pits, designated excavations, and commercial sources. We'll see that as we progress. Surfacing, something a little bit different now. Prime coat and attack coat. Now, if you recall your methods subject, if you pull out your book and just briefly read up on roadworks there, you notice, or you'll be basically refreshed in terms of these definitions. Prime coat, tack coat, and asphalt. All right, prime coat, tack coat, we're going to be looking at area or volume, meters. Right, we know by now what these two are. Asphalt, right, it's going to be reduced to ton, but at the same time, if we have volume, we still need to apply it to the density of asphalt. And what is the density of asphalt? 2080. Okay, so here's a new number for you to commit to memory. Just like in steel, we had 7850 as the density of steel. Now we're talking asphalt. Asphalt, all right? Last one, concrete curbs. Notice, it is not volume. It's in meters. Precast or in situ. Precast curbs, we buy a lot of them. All right, so it'd probably be easier to buy them and lay them. Therefore, we're not going to be calculating volume of 20 MPa concrete or 15 MPa concrete or that type of calculation. But you'll see that as we progress in an example. All right, so let's look at the first example. All right, now I've basically created this first example, very simple to understand, and basically gets the concepts across. So let's look at it. Measure the quantities for roadworks for the area bounded by A, B, C, D. Right? A, B, C, D. The site was handed over with the ground level as indicated on section XX. Now you'll be given this, right? So I need to fold this in. This is come off. Right, here's XX and here's XX. Right. So what we did was we took a section, we cut it, and this is what it looks like. Right. So we've got a subgrade that's basically whatever we found there specific to that site. We put in a subbase, which is that area there. We put in a base, which is that area there. We put in the premix and the tack coat located in that particular area. Right, so subgrade to be compacted to a depth of 150 millimeters at 95% mod ash at 95. Now we're given a condition, so we have to apply that condition to that particular area of that pavement. Therefore, it has to be quantified. You may think it's already there, so why would you have to apply extra work to it? Because we need to rip, compact, and get that percentage of compaction. Right. Number 3, subbase consists of 150 millimeters thick crushed stone compacted to 98 mod patch stone. Right. Therefore, we have to bring in and compact to 98 for your subbase. The base consists of 100 millimeter thick crushed quarry stone compacted to 100. So we got 100% compaction here. Then we put in a spray coat of 2 liters bitumen emulsion per square meter. So that goes in somewhere there. And the surface is 20 millimeters pre-mixed, hot laid, and rolled. So this dark section is the wearing cost, the tar that you're familiar with. Concrete in curbs is 20 MPa. Premix density, as I already mentioned, is 2080 kg per meter cube. All right, so let's understand the drawing now. We've got our house here. I suspect there is his garage, and he wants some curbing. He wants his driveway tarred and tied in with the municipal road. And we have a nice little curve there and a nice curve there, basically your fishtail. If you remember your basic road design, that road turns or intersects, and we got a nice curve there. All right. So this is the dimension of the curbing, right? You may be wondering why. We're going to need this, right? And the curbing basically ties in with the municipal and climbs all the way there on both sides. All right, and this, now interesting enough, if you look, subbase and subgrade sit below the curb. So the base area is going to be smaller than the subbase area and the subgrade area. All right, because it's confined within the curb, which has a thickness of 180. All right, so that's basically how you look into this drawing. All right, 2.5 meter tells me what? Tells me that the radius, if that is the center, the radius is 2.5 meters, right? 2.5 meters from the edge of the curb or the outside of the curb. All right, now let's attempt this. All right, where's this drawing? Right, so drawing back once more. All right, now I've reduced it, and we find here your radius. We've got distance of 8 meters. All right, and now we need to break this down into easier parts to manage or handle or to calculate. All right, now let's call this area here area 1. All right, and then let's cut it off here and call this area 2. And let's do an interesting one here. A3. So we've broken down the sketch into more familiar parts. All right, so we're going to look at A1, A2, and A3. Thing is, A1 will be completely equal to that because the radius is the same. All right. Now, the most difficult thing about quantifying roads quantities is A1. Once you've done A1 and got the hang of it, A2, A3, easy peasy. All right. So let's look at A1. What are we trying to find? What are we trying to find? Here's your A1. I want to find this area of the curve bounded by the thickness of the curves. And I want to find out this area here within the curve. Right, and what if I find on this side is times 2 because it's equal to the other side? This, understanding the sketch here, is literally, from my experience, the most difficult thing to do in basic roads quantification. All right, so let's start. Now, let's start with A1. Notice, I'm not going into site clearance and earth excavations because we don't know the area to work with. All right, so let's look at A1. A1. All right, we said that's 2.5 plus the width of the curb. All right, what did I do there? Remember, this is a square. That's the radius. The radius equals it. So that distance equal to that distance, that times that, and we got the full area of A1. All right, now let's find the area of this guy here, the curve. And let's call it area of curve. See, easy minus high, let's call it big R. And let's say from here to here is our radius. And then from here to here is big R, right? So here's big R, is small r. All right, but what did we find here? All right, we found for the full circle, but this is just quarter of that circle, isn't it? So that is divided now by how much? 4. All right, so the area of this curve only is that. But if we consider this is the area of this entire portion around, and we only need that portion. Therefore, divided by 4. All right, we found that. Now, how much of this constitute this entire thing? I'm finding now area of the corner. I'm saying total area minus All right, so I found this particular area there. All right, why 4? Because quarter, right? That's for the entire, from there to there, the entire area of the circle. But I just need that part, a quarter of it. Then therefore divided by 4 plus that section there, right? Gives me 5.46. We know the complete area, and therefore the little portion that we're looking for is 1.54 square meters. That's it, right? That's the most difficult thing about Rhodes quantities, understanding and quantifying that. All right, now we've done with that A1. Let's look at A2. What did we say A2 was? A2 is this easy section here, right? And the dimensions we know are given 4.0 times 8.0, and we're getting 32 meters squared. We want A3 there after this little portion. And what do we say? We want from there to there, which is 3.6 times the height, which is actually the radius, 2.5, and we're getting 9.1 meters squared. So, area of driveway, including, now this is important, including curbs. Right, 2, right, 2, that plus that, because of that plus that. That's why times 2, which is 0.73 plus 1.54 plus that 32 plus that A3 9.1, and we get 45.64 meters squared. Now, this is the starting point for what you already know, which is what? Which is basically number 1, site clearance. All right, so let's start. Site clearance. (45.64 meters squared), which we found now. All right, 2, excavation. All right, so what is the effective depth of our normal material? All right, they say in subgrade, we got some work to do there, right? So that's 150 there. Subbase, we got some work to do there, basically put in that. We've got a base given as, right, and gives us a total of 400 millimeters, right? Therefore, 400 minus 150 topsoil that we've already taken off. And we've got an effective depth of 250 millimeters at an area of 45.64 meters squared. We've got a total volume of 11.41 meter cube. Right, so we've quantified that. Now careful, somewhere in this depth, let's put some depths in. I could say you've got rock. Therefore, now you're going to have an extra over component coming in. All right, now 3 we know as overhaul. Is there a condition for overhaul in the question? We're not given a condition for overhaul. I suspect the homeowner wants to use that extra material somewhere else, so he's not giving the contractor the opportunity to cut it away. So overhaul over here is going to be 0. if you're wondering about that. And if you want to quantify, if you leave it out, that's fine also. Right? I'm not going to attach marks to overall. All right. Now let's talk about this thing. Layerworks. Layerworks being the layers of the road or the pavement. All right, let's look at 4.1. Starting from the bottom, subgrade. I have and you have to start from the bottom. We know the area where the subgrade lies, 0.15 is the depth. That's 6.846 meter cube. And let's go back to the sketch. All right, subgrade, here's it here. All right, what's next? Subbase. Let's call it 4.2. Same area. How do I know it's same area? Because if you look at the subgrade, it's everything underneath. If you look at the subbase, it's from there to there. So it's everything underneath. Therefore, the area is still the same. And naturally, it gives us the same volume for. Now, guys, this is like easy marks. 2 marks here, 2 marks here. Easy marks, right? So from my observations of previous years, Roadworks has a component of about 20 marks, give or take a few. It's the easiest 20 marks you're ever going to make, if not for another easy 20 marks from steelwork. So we're looking at potential 35 to 45 marks in the bag out of 120 or 150 mark paper in your exam. All right, 4.3, let's look at the base. Now, base, here's a problem. Here's a problem. Look at the sketch. The base sits within the curve or is confined by the curve. So the area of the base is naturally going to be more or less. It's going to be less. So basically, we're going to find the area minus the area of the curves. Let's look at that. All right, so let's say base is equal to 45.64, subtract area of all curves. All right, now let's find the area of all the curves. All right, 0.73 times 2. Remember, we found this area here. Right? We found this to be 0.73 meters squared. So there's another one on this side. So times 2. Yes, times 2 there. All right. Plus 8 meters. It says from the radius point there to there, it's 8.5. Oh, it's 8.5. It's 8.5 meters. All right. And it's on both sides. All right. 8.5 times 0.18. And both sides times 2. All right, and what do you get there? $4.52 meters squared is now what in terms of our sketch? 4.52 meters squared represents all this area taken up by the curbing. There to there and there to there times 2. All right, therefore 45.64 is a complete area. Subtract 4.52 meters squared And we get what? 45.64 subtract 4.52. We're getting 41.12 meter cubed, right? Volume. And we know the depth is given as 100 millimeters. All right? Times 0.1, and we're getting a volume of 4.11 meter cubed. Right, so what did we quantify there? We quantified the base. The base being all that bound by the curve. Right, let's move on to the next one, 4.4. Let's say spray coat. You're saying 41.12 is the area. Spray coat. Remember, the spray coat is happening underneath this line here. Spray coat, basically your tack coat, right? And the condition says in your question, it's given as 2 liters per square meters times 2, and we're getting what? Let's see, 82.24 liters. All right, let's look at the last one, the 4.5 premix. We're saying 41.12 times premix thickness of 0.2 meters, which is 20 moles. All right, times density, as I mentioned earlier. All right, times 0.02 times 2080, and we're getting a volume of 1710.59, which is equivalent to what? 1.71 tons. 1.71 tons. All right, now we finished with all the labels. Let's move on to the last item. Let's call it concrete. Now carefully here. Do not draw on your knowledge from concrete quantities. All right, and let's call it curbs. And what are we trying to find here? What are we trying to find? We're trying to find the length. Remember the unit in the notes, it said meter. We're trying to find the length from here to here times 2 for both sides. Okay, so good. Let's look at the perimeter of this curve, right? 2 pi r is perimeter, am I right? Okay, but now we are only using a quarter of that radius. So we're gonna divide by 4. All right? And we're saying 2 pi times 2.5 divided by 4, and we're getting 3.93 meters. Now you're gonna ask why 2.5 and not, you're gonna ask why 2.5 and not 2.68, which is the entire thing. All right, let me explain. All right, so here's an eraser. Here's another eraser. Yes, I do have another one. All right, so I've got 3 erasers. Okay, All right, 3 erases. Now, let's assume these are curves. All right. I want it to hug this. And there we go. It's hugging there. It's hugging there. And it's hugging there. So if I find the perimeter of this side automatically catches up, isn't it? But if I define the perimeter of this, now this actually puts it in here, doesn't it? So you're going to be buying more than you need, which is wrong, which is a loss. Therefore, that's why I'm using the inner radius as the guiding radius to quantify curves. All right. So if you have that question in your back of your mind, there's the answer. All right, there's the answer. And that's why. All right. So total curving, you're looking at 2 times what's this? 3.93 plus 8, right? Both sides. And we're getting a value of 23.86 meters. And you can't buy that portion, you'll have to buy 24 meters. All right, and that basically quantifies all the items in this question. Now all that remains is to tabulate it in our bullet points. All right, so let's do that. Let's say the quantities, let's go here. Let's say that the sands, let's say there's a factor there, get some dimensions, bigger column, totals, description, unit. Right, sands, 1200. All right, let's look at measurement list. All right, you can put in the dimensions and the total there. Unit will be 1. All right. Unless I give you the addendum for roads, then you will have to put in a clause number there. All right, 2 excavation. Where's the base? All right, so in short, that's basically quantification for your basic roadworks. As you've observed, right, fairly straightforward geometry. And as I mentioned, most difficult thing here is this sort of thing here. Right, that's the most difficult thing. Now, if you look at past year papers or past year exam questions for this subsection, I'll put up some exam question papers and you'll observe. I've given a huge area. I've given something like that ties into a municipal road. And alternatively, I've given something like the same. Just to make it more complicated, I gave different radius there. Different radius there. All right, so that's the most complicated thing about roadworks. And if you look at the example, I put some kind of structure there, and this entire area here, all the way to the municipal road, is your paving area. And if you look at this, once again, another structure here, like a warehouse or a garage or something, right? And then you have to quantify the paving there, all the way there. So the most difficult thing is basically that portion. And if you know the area of this entire thing, subtract the area of this, then you have the area for all your paving. Right? Just to give you a heads up on how to expect. Don't find or feel that this thing is intimidating now because you have to do roadworks. The most intimidating thing is still that curve, which you already have seen is not too difficult. Right? Quantifying those corners, and maybe this was incorrect. Maybe there's a fishtail there and fishtail there. So there's more corners there on either side. Also be very careful. Observe the arrow. Is it on the inside or the outside? Right, because this arrow direction makes a difference, isn't it? Am I giving you the big radius or the small radius? Something to look out for in small print. All right, so that brings me to the end of roadworks. All right, and subsequently also the end of quantities. So if and when we do progress to test 2, this is where test 2 stops, all the way from earthworks to roadworks. All right.